Good morning, students. Welcome to Unibek Group of Schools, where education has been made affordable to all. Today, in our revision class, chemistry, we're going to talk about matter. And I believe you've heard of matter. I used to know matter as anything that have weight and occupy space, but today it's not that way. Today, matter is defined that as anything that have mass and occupies space. Now, what is mass? Mass is the quantity or amounts or matter in a substance. For example, matter. This is a matter. This is a matter. It has weight. It occupies space. Air is matter. It has weight. It occupies space. It has mass, and occupies space. Okay? Now, composition of matter. Matter is built up or made up of subparticles known as atoms, molecules, and ions. Now, we're going to discuss this under the particulate state of matter in our next class. Now, property of matter. Property of matter. Matter has several properties. But we can see these properties in two ways. We have the physical properties. We have the chemical properties. Now, what are these physical and chemical properties? Physical properties are those properties that are associated with physical change, whereas chemical properties are those properties associated with chemical changes. For example, physical properties, we have malleability. Malleability is the ability of metals to be beaten into shapes. For example, you have most of your metal work, your iron doors and iron gates, they are beaten into shapes. Okay? So we call it malleability. They have this characteristic. Now, we have ductility. You might ask me, what is ductility? Ductility is the ability of a metal to be drawn into wire. Okay, you can see electric wires. Okay, most of the electric wires, like the high tension wire, is made of silver. We have copper. Okay, they have the ability to be drawn into wire. That property is known as ductility. Now we have other properties, so that boiling point, melting point. We have melting point. Okay, and in addition, all the separation techniques. Okay, we're going to do that in the lab, where we can separate two or more items or constituents combined together. Okay, for example, you have fractional distillation. Okay, you have sieving. All these are what? Physical properties. Now, what are the chemical properties? Example of such chemical properties are the rusting of iron. Okay, iron has the ability to rust. In most of your houses, you must must have seen rust in one way or the other. Rusted nails, okay, rusted gates, okay. So that is an example of a chemical property, okay. We can also talk about decay of leaves, okay. Those are chemical properties. Another very important one you see around you is the fading of your clothes, okay. They all are chemical properties, okay. Emphatically, we also have burning. Burning is a chemical property, okay. Burning, you see burning everywhere, is a what? Chemical property. Now, we said earlier on that physical properties are those properties that are associated with physical change. Now the question is, what is physical change? What is physical change? Or what are physical changes? Physical changes are those changes that are reversible. It means you can reverse them, okay? For example, if you have ice and you have your normal water, okay? Look at this now. This is ice. Ice is water, okay? Solid form of water. We also have the liquid form of water. You understand what I'm saying? Now, if you solidify ice and solidify water, you get ice. Okay? Now, if you melt it, you get your water. You see, it's reversible. You can say, you can put it this way. Okay? If you liquefy, you get this. If you solidify, you get this. That's why I say it is what? Reversible. Okay? And in which no new substance is formed. You discover that no new substance is formed. It's still water. The ice is still solid form of water, and the liquid form is still water. Even if you go further to heat this, you get the gas, the gaseous form, okay, which is the steam. You understand? Which is the steam. Now, if you cool the steam in the process known as condensation, you still get water. Now, everything boils down to what? Water. Okay, so we have seen that the physical changes, they are reversible, and what? No new substances are formed. On the other hand, chemical changes are those changes in which new substances are formed, okay, and they are not reversible. They cannot be reversed because new substances are formed. For example, if your clothes fades, do you get it back? No. No matter how you dye it, it's a faded clothes. Okay, new substance is formed, but you can't get it back to its original state. You understand what I'm saying? Now, when a leaf decay, or when people die and decay, do you get them back? No. You see, that process is known as what? When leaf decay, they form humus, fertilizer, organic fertilizer. You see, it has gone from a leaf to an organic fertilizer. That's what I'm saying. New substances are what? Formed. Okay? When you burn substances, new substances are formed. If your material burns, the next thing you get is ash, is it not? New substances are formed, and you cannot take your ash back to whatever has been burnt. Okay? We also talked about rusted nail. Okay, you can prevent corrosion or rusting, but you cannot get back the new substance. Once anything rusts, it becomes a rusted stuff. You understand what I'm saying? Now, having said that, we're going to, before we get into elements, compounds, and mixture, we're going to look at states of matter. Before we move further, we're going to look at the state of matter very briefly. As you can see here, I touched that earlier on, but for clarity, we have basically three states of matter. Basically, three states of matter. we have the solid, we have the liquid, and we have the gas. Now, water is very, very peculiar. Okay, we call it universal solvent. It's a peculiar substance. It is only water that can comfortably and conveniently go through these three phases. For example, like we stated earlier on, the solid form of water is ice. When you solidify, you get ice. When you freeze, the liquid form of water is the liquid water. Okay. Now, when you heat further, you get steam. For those of you who cook at home, if you cook at home, you discover that when you cook and you cover the pot, okay, now you allow it for some time. When you open the pot, you see droplets of water on the cover. That's called the steam that have condensed, okay? Or when you open the pot, you see steam. That steam can even burn you. That's the gaseous form of water. So you discover that water can go through the solid, liquid, and what gaseous phase. Now, however, there are substances that can go through the liquid state from the solid state to the gas. It keeps the liquid state. Example of such substance is iodine. Iodine, or better still at home. How many of you use camphor? I know our mothers used to put it inside their box to prevent or to scare away cockroach and all that from eating up the clothes. Now, this camphor, okay, or iodine, they are solids. Now, they don't go through the liquid stage, rather they go straight to what? Gaseous state. So they skip the liquid state and from solid to what? Gas. That phenomenon is known as sublimation. Sublimation. You will say it has sublimed. Okay? Now we can have the reverse, from gas to liquid. That is known as condensation. This is how rain is formed. Okay? It's important to note that when a gas, okay, or steam meets a cool body, it will lose its kinetic energy and become liquid. That's how rain is formed. Okay? Now, we also have, you can take from liquid to gaseous, is known as evaporation. From liquid to gas is known as what? Evaporation. If you take from liquid to solid, is freezing. It's freezing. So you can see that with this illustration, we have basically three states of matter, but not all elements go through these three states. The only element that goes through these three states is water. Okay, I hope you're following. Now let's go to the last stage here. We have elements. What are elements? Elements. Now it's important to note that elements are substances, okay, that cannot be split. They cannot be split into any simpler they cannot be split into simpler units by any known chemical process. Okay, so elements cannot be what? Split. Example of such elements, you have hydrogen, okay, we have lithium, we have calcium. They cannot be split into what? Simpler what? Units by any known what? By any known chemical process. Now let's look at compounds. What are compounds? Compounds contain two or more substances. Compounds contain two or more elements. They are substance which contains two or more elements chemically combined together. Okay, so any substance that contains two or more elements chemically combined together and known as what? Compound. Now you can have example. If you have water, water is a compound. Why? Because it contains two atoms of hydrogen and one atom of oxygen. You have calcium trioxocarbonate. Now, calcium trioxocarbonate is a compound that comprises calcium, carbon, and three atoms of oxygen. So you see, these combine together. Okay. Now, other example of compounds are sand. Sand is a compound. Take note. Okay. We have other examples. Now, having said that, let's go to mixtures. What are mixtures? Very important to note. Mixtures is the combination or substance that contains two or more constituents. Take note. Constituents. But compounds contains two or more elements. So this contains what? Two or more constituents that can be separated by its physical means. Now, compounds cannot be separated by physical means. Okay? But mixtures can be separated by what? Physical means. Example of mixtures: air. Air is a mixture of gases. Okay? Example: urine. Urine. Okay, but urea is a compound. But urine, okay, is a mixture. We have example. We have flood water. Flood water is a mixture of sand, okay, and water. So you have several mixtures, okay. So having said that, in conclusion, we have two types of mixture. We have the homogeneous mixture and heterogeneous mixture. What are homogeneous mixtures? Are those mixtures in which their constituents are uniform, in which their constituents are uniform. Example: there is salt in this water, but you can't tell if there's salt in this water until you taste it. Why? Because the constituents, the salt and the water, are uniform. Okay, so you can't tell by mere looking at it, but the only way you can tell that this is when you take and test. That's why it's very dangerous. Okay, someone can easily be poisoned. People have been poisoned. Okay, because somebody can just put what they want to put in your Coca-Cola, okay, or soft drink, and present to you. You don't know what's inside. Okay, because it is what? A homogeneous mixture. On the other hand, heterogeneous mixtures. You see this, you can actually tell. A heterogeneous mixture, they are not uniform. For example, this is water and sand. You discover that there are two layers. You have your sand below, okay, it has sedimented, and you have your water above. Okay, so this is a pure heterogeneous mixture. I think at this juncture, we're going to call this class an end. I believe that you were able to follow up. Please, if there are areas where you have confusions, or you have questions, do write them down. And in our Zoom classes scheduled for Fridays, you bring up those questions, we trash them together and make further clarification. Keep reading. Don't stop reading. The battle is on. Thank you, and God bless you. I wish you all the best. Amen.